Our second panel is titled Energy Transformation Across Every Scenario, from Deserts to Cities. While our first panel focused on market value and growth opportunities, this next discussion looks more closely at real-world applications. Today, solar and storage are being used in more and more scenarios, from local communities and microgrids to deserts, oceans, and remote areas. At the same time, new applications areas such as AI data centers, industrial parks, transportation, agriculture, and mining are creating fresh demand for more advanced and flexible energy solutions. To moderate this session, I'm very pleased to welcome Shimeng Wei, Vice President of Renewable, PV, ESS, and PCS at TÜV Nord. Shimeng has more than 15 years of experience in testing and certification for photovoltaic and energy storage products. He brings deep technical expertise to this discussion. Shimeng, over to you.
Thank you, Hisanari. Hello, everyone. I'm Shimeng from TÜV Nord, and I'm very pleased to moderate our second panel discussion for today. So our topic is the energy transformation across every scenario, from deserts to cities. So what is becoming increasingly clear is that the solar and storage are no longer following a one-size-fits-all model. Instead, we are seeing more and more solutions developed around the needs of specifications of scenarios. For example, some products are designed specially for desert conditions, while some others are developed for rooftop environments and particularly operating challenges such as bird droppings and heavy soiling. This shows a clear industry trend that solar plus storage solutions are becoming more scenario-driven and more customized. So in this session, we will focus on three things. First, how full scenario energy solutions are evolving. Second, the technology challenges in extreme environments. And the last is the emerging application scenarios that may shape the next stage of our growth. So now let me quickly introduce our panelists. You may say hi to the audiences, and I want to make sure I'm pronouncing everyone's name correctly. So also feel free to correct me if I'm wrong. So first is Engineer Justin Sim, President of Malaysia Photovoltaic and Sustainable Energy Industry Association. Welcome.
Thanks.
Stephen Adwong'a Ochieng, CEO of Miale Solar.
Thank you.
Welcome here. Reyland Nepomuceno, CSO of Raslag Corporation.
Hi, everyone. Happy to be here.
Hisanari ONOUCHI, Deputy CTO of Cybrid Technologies Incorporated.
Hello, nice meeting you. Nice to be here. Thank you.
Krunal Patel, Director of BESS CTS Renewables in ACWA Power.
Hello. Hello, everyone. Nice to have you here. Thank you.
Dino Ablakovic, Director of Microgrid Digital Solutions in Univers. Maybe you can check your mic because somehow we can't hear. Thank you. Dr. Helen Zhou, Head of Module Research and Development of JA Solar.
Hello, glad to be here.
And last is Yankun, Head of Smart Microgrid Center of JA Smart Renergy in JA Solar.
Hello, everyone. Glad to meet you here.
Great. Thank you all for joining us. So now let's get started. So for our first round, I'd like to start with the bigger picture. We often hear the term full scenario solutions. Solar and storage are increasingly being designed for different environments, different use cases, and different energy needs. So let me start with Stephen. Stephen, you've worked across both urban and rural markets in Kenya. From what you are seeing on the ground, how do you view the development trend of full scenario solar plus storage solutions for today?
From what we are seeing on the ground in Kenya, the shift towards full-scale scenario solar plus storage is no longer theoretical. It's actively happening, driven by necessity rather than just innovation. Historically, the solutions were quite segmented, with the urban C&I focused on cost savings, which were through grid-tie systems, while the rural deployment were primarily off-grid for basic access. But today, that distinction is fading. We are seeing convergence towards hybrid, flexible systems that can operate multiple scenarios, grid connected, weak grid, off grid, within the same architecture. In urban areas, particularly cities like Nairobi, Kisumu, Mombasa, commercial clients are increasingly integrating storage, not just for backup, but for energy cost optimization, peak shaving, resilience against grid instability. The grid is available, but reliability in some part of the country is basically driving demand for smarter systems. In the rural and the peri-urban areas, the focus is a bit different. Systems are being designed for energy dependence and reliability, often supporting productive use, such as agro-processing and small industries. What is notable in this setting that we are no longer deploying basic systems. We are deploying scalable modular solutions that can grow with demand. So the key trend is this. We are moving from single purpose system to adaptive energy systems, solutions that are not just designed for where the client is today, but where the energy demand is going. Thank you.
Thank you very much, Stephen. Okay, let me bring in Dino. Dino, with your global experience in microgrids and digital energy systems, what major trends are driven of the full scenario deployment across different markets? Can you share some insights for this? Thanks.
Yes, of course. So actually, we have here three major trends that I would like to put out, and it's like 3Ds. It is decarbonization, decentralization, and digitalization. So these are global three trends that we see happening everywhere. So through decarbonization, everything is being electrified. And some major components of our lives, like transportation, vehicles, trains, ships, everything is being electrified. Another one, and especially in Europe, where I am, is heating. So we are moving from traditionally fossil heating, primarily gas, to electrical heating, which means heat pumps. And finally, the whole industry is being decarbonized. So from glass to steel, and even lighter segments of the industry. So that's the number one. Then we have decentralization, which is something being driven by the grid congestions. So we know that the grid development is not following the development of the renewables. So both transmission and distribution grids are being overloaded due to increased loads in some places, but due to increased generation, renewable generation in other places. And we could actually say that decentralization is driving the decarbonization is driving decentralization. And this is actually where microgrids thrive. So they provide a solution how to integrate co-located renewable generation, and this is primarily solar and storage, with the load. And finally, digitalization. It's such an important part of the grid today, where we are seeing a trend that we have full connectivity between the end customer and the grid operator. In Germany, for example, there is a law now that defines that every load which is larger than 4.2 kilowatt, it is so small, that it has to have a digital interface to the grid operator. So we are definitely moving in the area where we will have a fully digitalized energy system.
Okay, thank you for your insights. So let me come to Hisanari. Hisanari, with a background in PV materials and technology innovation, how are the new technologies helping to make these more diverse application scenarios possible? Can you share some ideas?
Okay, thanks for the question. So to meet technology demand for the diverse environment, we need to carefully pay attention to the market demand, market technology demand, how those modules used in a harsh environment. And then we need to connect market demand to the technological seed in the supply chain demand. So we are specialized in connecting the market demand and the technical seed. So we have, of course, close relationship with the module suppliers, and then also material suppliers as well. So we are always challenging to the how to develop our technology using existing technology. So we believe we need to develop new technology to use current technology and then future demand. Thank you.
Okay, thank you. Let me turn to Justin then. Justin, from your industry perspective in Southeast Asia, how are the full scenario solutions changing the way that the market thinks about energy development?
I think from the Southeast Asia, especially from Malaysia, and also I think the neighboring country, we used to be just a fundamental project-based thinking, right? We are shifting to the system-based thinking. For the past 10 to 15 years, we are only just to build solar, connect to the grid. That's it, just to sell the energy, right? To make sure that the first is the commercially viable, that we can have the saving for our customer. But I think up to today is our grid is started to constrain. I'm worried about the penetration limit issue, and also the customer are more sophisticated, right? More complex. So I think the full scenario solution, especially like solar plus storage, are changing the conversation in the three key ways, right? First, the generation to the reliabilities. Second is the standalone access to integrated ecosystem. And third is a lower cost to the highest value, right? Like for our country, like in Malaysia, that the government are putting the policy on the rooftop solar that more than 1 megawatt hours solar that need to equip with the battery energy storage with the minimum 1 hours, just to ensure that the intermittency issue can be resolved before the distribution level of network it can be stabilized, right? For the utility scale of a solar system, they need to be equipped with the 4 hours battery for our CREST program. So this is the change of the entire energy development for the past. And I think we are here is looking shifting from a more critical and full scenario solution, and it's not that optional anymore. So it's necessary to unlock the higher renewable energy penetration, right? So at MPSEA, we believe the future is not just the solar anymore. It will be the hybrid, solar equipped to the technology, energy storage technology, and also is the engineers energy solution tailored to each scenario. Yeah, thanks.
Yeah, thank you very much. So now let me bring in Dr. Zhou. Dr. Zhou, as more players are moving from a one-size-fits-all product approach to now the scenario-based solutions. So I want to ask, how is J Solar adopting and adapting your module technology and product strategy to meet these more customized needs?
Okay, yes, with the development of PV industry, solar modules have been widely used in different scenarios, and the demands on module suppliers are increasing. We need to have high efficiency, high reliability, and low cost. And but actually, JA Solar is a navigator in this field. We have a three-step strategy on providing scenario-based solutions. First, deepening customer engagement. We prioritize understanding our customers' real needs to ensure our solutions are precisely tailored. And second, we need to identify the scenario-specific requirements. We pinpoint the enhanced performance needed for each particular environment. For example, for desert application, we have identified at least 4 critical factors beyond the standard modules. And better resistance to sand abrasion, higher tolerance to larger temperature swings, and stronger UV resistance. And also, because there are a lot of sand in desert area, we need to try our best to reduce the sand accumulation on the module surface for better energy generation. And finally, based on the pain points being recognized, we need to develop targeted solutions. And we address each challenge with customized measures, which may involve using higher grade encapsulation material, just our cooperation with the Cybrid or some other material suppliers. And sometimes we need to redesign the module, or even we need to develop a totally new system, like the recently very popular space PV. Yeah, that's JA's strategy on the scenario-based solutions. Thanks.
Okay, thank you very much. So from this first round, we can already see a clear direction. The industry is moving towards solutions that are much more integrated, flexible, and also scenario-driven. So I would now like to move to the second part of our discussion. So as solar and storage move into deserts, coastal areas, and other demanding environments, technical reliability becomes also a much more important factors in this part. So let me start with Krunal. Krunal, the ACWA power has experience with large-scale projects in demanding conditions. So what are the biggest challenges when deploying solar plus storage at scale in those environments?
Hello, everyone. If I talk about our experience delivering large-scale solar plus storage projects, particularly in the harsh and desert environment condition, I would say the challenges go well beyond the standard utility scale deployment. So the first, if I will start with the environment itself, is a major factor. Here, the high ambient temperature, often exceeding more than 50 degrees and directly impacting the various parameters like battery performance, accelerated the degradation profile, and we observed increased the cooling requirements. So at the same time, the dust and sandstorm also reduce the solar generation and increase the O&M intensity, especially for the cleaning and HVAC systems. So in coastal desert, the corrosion adds also another layer of the complexity what we observed. If I talk about the second, the harsh environment condition which will affect us in the various projects is meeting the performance guarantees becomes the more challenging nowadays. When you move from the lab conditions requirement to the operating environments, the factors like auxiliary consumption, partial loading, the thermal derating can significantly impact the round trip efficiencies as well as the availability of the plant. And this makes the definitions of the measurement points, whether the DC, AC, MV level, commercially critical in the various contracts. If I talk about the third point, which is very important, is the grid integration is becoming increasingly complex, and especially in the remote or big grid conditions. So low short circuit ratio and unstable network require advanced capabilities of the grid forming inverters, the fast frequency response, and the black start functionality. The integrating new BESS systems alongside the existing infrastructure on the same bus bar is still technically a demanding area. And in the last point, if I talk about, is in addition, the logistic and construction in the remote location presents the real challenges from the transportation of large equipment and ability of the skilled manpower. But although based on our various experience in our the projects in Middle East region, we come out with the various solution discussion with the various contractors and the products OEM, and our projects are successfully running in this region. Thank you.
Yeah, thank you, Krunal. So we are also seeing a lot of problems in the grid compliance or grid connections part from to north side, where we, as a third party, we see different grid operators has now new requirements, especially in Europe as well. Big countries like Germany, like Austria nowadays, the Czech Republic also has some new requirements. So this kind of thing is also quite important to the new age of these projects. Okay, now let me bring in Reyland. So Reyland, from a developer's perspective, how do you evaluate the risk of the projects in challenging environments, and how you decide whether they are bankable or not? Can you share some ideas?
Yeah, so basically, Raslag is an experienced greenfield solar developer. We have developed our own checklist. So part of this checklist, we have a technical site assessment. So this is really important that you do your due diligence with the technical site assessment. So part of it is environment and weather hazards. Like in our case in the Philippines, we are hit by a lot of storms. There's a lot of flooding, so we have to take that into consideration when we evaluate the area. Like, is it a flood prone area or something like that? And irrigation, of course, the variability of irrigation. So this is very important because this dictates your production in terms of solar. Okay, and then the topography, like you have to check risk, like is there shading, is there an irregular shape of the land, and all of that you have to take that into consideration because it could affect your production. And seismic activity, of course, you have to address all of these risks. And something that is taken for granted by a lot, but you need to do soil testing. Soil testing is very important because, you know, if you don't do soil testing, you can run into problems later on. Like you can have cost overruns. Like let's say you encounter soft soil later on, like clay or something like that. So you have to scrape it off, and it will be a project cost overrun for you. So it's part of the due diligence to check it out early. And then ensure the land titles are legit. So, of course, land is the lifeblood of ground-mounted solar. So you have to look into these things. Right of way, of course, you need access to the area and the physical risks. Like, are there any insurgents or anything, other risks in the area? So you have to take all of those things into account. And then another thing that you have to consider is the grid interconnection. This may make or break your project. If you don't have a tapping point, then your project is dead. You cannot tap into the NGCP grid line, and the project will not fly. So it's very important to secure the tapping point as a first step. All right, and of course you can also do design. Like there are software like PVSys that can help you simulate the solar production. You can do a simulation like the type of solar panel used, the configuration, like is it the south facing or east west. You can do all of these simulations to get you the optimal setup for your, and you can also integrate BESS simulation with that. So these are the major things that you have to take into consideration. Of course, there are other factors like the financial, the legal aspects, but I think this is the most important. Thank you.
Thank you very much. Okay, now let me turn to Dr. Zhou. Dr. Zhou, so from J Solar's research and development perspective, how do you make sure your products are designed and validated to perform reliably in these harsher conditions?
Okay, to make sure our product can handle extreme environments, we focused on two main ways to guarantee the performance. The first one, all tests on new product are going beyond standard. Actually, during our R&D, we don't just rely on the existing REC standards, because standards often lag behind the real technology advances. I think all of us know it's normal. So we not only focus on the research and the development of new technology and the new product, we also pay a lot of attention on the new testing methods specified for the new module design. So to ensure a faster and reliable product development, we must create a faster evaluation system in advance and try to build a close relationship between the lab testing and real application scenarios. So it is very challenging. It means we need to do a lot of experiments and collect a lot of data for the final design. Also, we need to work together with our customers, with third-party certification and our other industry partners to finalize the testing method to an industry-recognized one. And second, except for the lab hash testing, JA insists to carry on comprehensive field performance testing on new products because we think the lab testing is totally not enough to validate the new products. So that's why JA maintains a complete field performance evaluation infrastructure, including our own internal testing field, third-party testing field, and also we get the monitor data from our customer installation. So inclusion in JA, every new product undergoes a first route of reliability and system evaluation before launching to the market. So we have the confidence our module performance can be very good, even under the most demanding conditions. Thank you.
Yeah, thanks for sharing the details. Let me come to Yankun. So from JA Solar's smart microgrid perspective, how do you design the systems that can stay stable and flexible in the remote or harsh operation conditions from your point of view?
Okay, thank you, Shimeng. Yeah, if we talk about the remote area or harsh operating condition for the power supply, I think where the electric power grid is weak or even no exist. So I think there are always some disadvantages embodied as some aspects as the first is insufficient power supply and limited the transmission and distribution capacity to result in overload, tripping, and frequently the power outages. And the second is in some remote areas located at the end of the power grid, the long transmission lines may lead to the high line losses, to making the terminal voltage decrease to fail to meet the requirement. So to address the issues of the power supply, so we developed the smart microgrid system. So it included the power, the photovoltaic and the power storage, and also we developed the management and the control system to provide the distributed energy system with the coordinate operation of photovoltaic, the energy storage and loads to provide the power solutions for some advantages, such as The first, the smart microgrid forms a localized energy supply system through the photovoltaic, the energy storage, and other distributed energy sources as the diesel generators to meet the essential power demand. So the photovoltaic power generated the power in daytime, as we know, and at the same time the store the surplus electricity in the storage system, and it will discharge to the to maintain the power supply at night. And this the photovoltaic plus energy storage system can to ensure the reliable power supply even where the fossil fuel supply is available. The second is the smart microgrid can improve the power quality as well. So by the the control system, it can collect the real-time data on the photovoltaic output, the energy storage, and the user loads to quickly stabilize the voltage and maintain the voltage at the grid within a reasonable range. The third is the smart microgrid enables remote monitoring and fault predict alarm for the microgrid. So it realized the real-time monitoring, the data collection, and the remote regulation of the microgrid system to actually predicts the equipment's failures if issues early warning in advance and remotely troubleshoots simple faults. So from the perspective of JA Smart Energy Solutions, the design and developed smart microgrid management and the control system ensures the stable operation and the flexible regulation of the microgrid in remote and harsh working conditions through the effective monitoring and the control of photovoltaic energy storage and loss. So it's my opinion. Thank you.
Thank you. So finally, let me turn to Hisanari. Hisanari, from a technology point of view, what do you see as the key technical challenges that still need to be solved when projects are deployed in extreme environments?
Okay, so yeah, I would like address those 2 points for developing the new technology for extreme conditions. So one is I would like to echo Dr. Zhou and J Solar said. So like one important point is how we can develop new evaluation method for the environment, severe extreme environments. So for example, if we want to bring PV modules to the space, environment will be completely different. Like no, of course there's no oxygen or no water in space, but the strong UV light, even like ozones and so many different circumstances in space. So in that case, I believe we need to develop new technology, new evaluation technologies. A little bit different story, but we have developed new technology which is that the downshift conversion material. At that point, to make our customer believing in our technology, we needed to develop a new new evaluation technology. So always, we are looking for new evaluation technology for new technology and new environment. And the second, we are trying to get ourselves prepared for the total solution. We are, of course, a capsule supplier and also base back sheet and front sheet and edge sheet and etc. And every kind of module component supplier. Yeah, we are supplying, developing and supplying those different kind of components. So of course, sometimes we cannot solve a specific issue with one component, but we try to, meet the customer requirements using other technologies. So we are trying to have a flexible mind to meet specific customer demand by any kind of all technologies. Thank you.
Thank you very much. So I'm closing this round. I think for this round, it makes one point very clear that expanding into more scenarios is just not about a wider deployment, but it's about designing for very different real-world conditions. So we've talked about the trends and also the challenges. So now let's focus on where the next opportunities are emerging. So let me start with Krunal. So ACWA Power has delivered many large-scale projects, especially in desert environment. But looking beyond traditional utility-scale deployment, what emerging applications or scenarios do you see that become more important? For example, in mining or major infrastructure or other new integrated energy use cases?
Thank you. Thank you for your questions on the very important topic. So beyond traditional utility scale applications, we see the various emerging and very exciting use cases. If I will start with the first is the mining is one of the fastest growing segment in this region, where these are the typically off-grid or diesel dependent operations. Now, where the solar plus storage can significantly reduce the fuel cost and improve the energy security, we are already seeing a shift towards the high renewable or even fully renewable microgrids. Large infrastructure, for example, such as airports, ports, rail networks, is also evolving in this particular region into integrated energy systems. These facilities are not just consuming power anymore, but they are also managing and optimizing the increasingly integrating the EV charging and also other flexible loads. If I talk about furthermore in detail about this emerging sector, we observe the industrial decarbonization, where solar and the storage are enabling the electrification of processes and integration with the technologies like green hydrogen, where green hydrogen is becoming one of the most important projects, specifically if I talk about the Saudi Arabia region. We also see the strong growth in island grids and isolated networks, where battery storage plays a central role in grid stability, often operating in grid forming mode. And furthermore, if I talk about as a futuristic, the requirement from the data center is also emerging as one of the major opportunity, which is driven by need for the reliable and around the clock clean energy solution. And by looking ahead with this success in these particular applications will depend on very few key factors which I wanted to talk about is an advanced energy management system for the real-time optimization is the most important part to play here. Then grid forming capability, which is also another feature which is must require in all PV plus BESS kind of a storage projects. A strong focus on the life cycle performance rather than just upfront cost is also one of the big factors which we are observing currently. So ultimately, as a conclusion, I could say the industry is moving from delivering individual assets to delivering fully integrated energy system, and that's where the real value is to be created. Thank you.
Right, thank you. So let me turn to Reyland. Reyland, from the experience in Philippines, where do you see the most promising opportunities for innovative solar applications today, especially, for example, in agriculture PV? And are there any practical application cases or models that you think are particularly worth highlighting from your side?
Yeah, actually, thank you for this question. We're very excited about this. So there are a lot of new solar use case applications happening right now. Like you mentioned about agrivoltaic. So we're actually implementing agrivoltaic in our own plant. So what it is basically, it addresses two of the main concerns, like which is clean energy and food security. So it's very much aligned to our ESG initiative. So it's a very promising use of land, where you have an optimal use of land, hybrid use of land. and some other things that are going on right now, like development. So as you know, ground-mounted solar, land is the lifeblood of solar. But then again, we're exploring other areas, like, for example, fish pen solar is growing right now. There's a lot of that ongoing, and also floating solar. So the difference, fish pen solar is still mounted, but floating, it's floating, what it is. And also EV charging. There's solar application happening right now for EV charging. So that's under development right now, but there are still only a few stations at the moment, but it's getting there. And then another thing that we're looking at is in Germany, in particular, Germany has developed solar wall panels. So instead of having a roof deck, you now have a solar wall panel. You can use it as a fence. So it's not, we haven't seen any implementation yet in Asia, but I believe this is something that's coming very soon. So excited about these things. Thank you.
Thank you so much. Okay, so let me come to Stephen. Stephen, in African markets, where do you see solar plus storage creating the most practical value today? Just for example, in areas like community powers, agriculture, or like off-grid access.
So in the African market, solar plus storage delivers the most immediate and practical value, where it directly supports economic productivity and reliability of operations. First, commercial and industrial applications remains the strongest use case today, because whether it's businesses doing manufacturing, hospitality, retail, they cannot afford downtime. The solar plus storage provides the predictable energy cost and operational continuity, considering that most of the African grid is unreliable and is inconsistent. Second, agriculture is high impact and still under-penetrated opportunity. In many parts of Africa, access to renewable energy can transform agricultural value chains from irrigations, cold storages, to processing. So you find that solar plus storage enable farmers and cooperative societies to move from subsistence to commercial scale operations, reducing post-harvest losses and increasing income stability. Third, community and institutional power systems such as schools, health facilities, and mini-grids are creating strong social and economic returns. They're not just electrification projects anymore. They're becoming anchors for local economic activities, which enables the SMEs, digital access, and essential services. Lastly, off-grid and weak grid access remains critical, but the model is evolving. It is no longer just about first-time access. It is about quality, reliability, and ability to support income-generating activity. So overall, the real value of storage in Africa is not just in energy provision. It is in unlocking economic potential, improving resilience, and enabling communities and businesses to operate with certainty. Thank you.
Good, thank you. Okay, so let me come to Dino. So with digitalization becoming more important, how is solar plus storage being integrated into new scenarios such like AI data centers, smart grids, and like virtual power plants? There's something you can share your insights.
Yes, sure. So yeah, data centers are definitely one of the newest trends, which is causing a lot of trouble in terms of grid connections. And I was involved in several data center designs, and while they're all different in terms of their energy needs, they have different sizes, they actually all use renewable energy, and this is primarily solar, which comes with storage. The reason for this is actually, which I mentioned before, decarbonization. They need to have a green energy supply. And here we have two options. One is the PPA from a distant PV plant, And the other one is the collocation and integration into a microgrid. And the microgrid option actually has a couple of very important advantages. It provides a way to connect both solar and storage on a medium voltage level, and to avoid the full high voltage equipment, which includes the transformer, the switches, breakers, the whole switch yard can actually be avoided, and this is an important capex part. And the other one is to avoid the grid charges, because when it is co-located, the energy flows directly from the solar and battery into a data center. So we are seeing these being deployed. And when we discussed, you know, the remote areas and harsh conditions and so on, data centers normally would come on a stable grid connection, but because the things are developing the way they are, we actually see a lot of issues in data centers not getting enough grid capacity. So there are countries, especially in Africa, where the grids are weak, unstable, and their battery together with solar can provide also resilience. But also in Europe, a lot of data centers just can't get enough grid capacity for what they need, and they need huge amounts of energy. And because of that, they have to integrate both solar and storage, sometimes even gas turbines, and to provide both the resilience and reliability which they need, but also the energy which the grid just can't provide. So yeah, data centers are definitely one of the big trends that is currently shaping the grid and the supply of all of the renewables.
Thank you very much. So let me come to Justin. Justin, from your regional view across Southeast Asia, which new application scenario do you see that will be growing the fastest in the next few years?
Thanks, Sam. I think from the regional point of view that you can see our Southeast Asia eventually rapidly grow on the demand side, focusing especially on the data centers. Individually in Malaysia, we already have a 5 gigawatt data centers in pipeline to be energized is running operation in 2027 or even earlier 2028. So those data center is actually operating by the MNC. They are actually RE100 registered company. So I think the solar and battery is needed to assist them on the achieving the RE100 agenda. Secondly is our rooftop solar industry, CNI, right? Looking in overall, the tariff structure has been revised in some of the country, even though in Malaysia. So some of the tariff has been shifted or split it to the time of use. So the battery energy storage is quite important to integrate it with our solar PV system to make sure that the solar energy can be supplied after the time of use period. So which is the higher tariff to make sure that can actually have enjoy the benefit of the cost optimization as well as the peak sharing, energy independence. I think the third one is more on the remote and the island microgrid, right? I hear a lot from the panelists talking about the microinverters, grid forming, inverter-based system. Yes, in Southeast Asia, most of the islands, we are still relying on the diesel genset supply. Looking at the current situation where the diesel price is actually triples from the past few weeks. So this is one of the energy trilemma, energy crisis that we are actually facing off. Battery energy storage off-grid system need to be integrated fast enough to accelerate to make sure that we have an independent source of supply to actually maintain the islands and the remote area. Of course, for the utility scale, yes, we are still adopting utilities type of battery energy storage to support the grid constraint, the curtailment, the frequency control, and also to make sure that we are able to replace the conventional type of power plant in future. Yeah, that's it. Thank you.
Thank you, Justin. So to the final question, I would like to come to Yankun. So under the development of the new power systems, smart microgrids are becoming an increasingly important solution for improving flexibility, resilience, and energy value. So from J Solar Solutions perspective, what are the key advantages of the advanced smart microgrid solutions in these emerging application scenarios that you have?
Okay, thank you, Shimeng. So I think the core advantages of advanced smart microgrid in emerging application scenarios is from four aspects. It's from the power security, the power reliability, and the low carbon performance and the economy. So the four aspects. The first one is the power security. As we know, as present, there's a large-scale integration of distributed photovoltaic and wind power into the main grid faces the core the pain points, such as some complex the power flow distribution and the large voltage and the frequency fluctuation, which led to the line overload, the missed operating of the protection devices, and even sometimes some local grid collapse. So JA's smart microgrid adopts the core solutions of local consumption and the local balance to resolve these difficulties at the source through specific technical configurations. So the second is reliability. As just we are talking about, we can take the example as the artificial intelligence data center. The AIDC, the core power demand of AIDC scenarios is the high reliability, the high power quality, and zero interruption. So the power outages, voltage fluctuations, or the frequency deviations will cause the server downtime, the data loss, and even the huge economic losses. So, and the traditional grid power supply model can hardly meet the requirements of the AIDC. The GE Smart Microgrid precisely solve this practical problem through targeted technical configurations, and have been we have been implemented in some data center supporting the projects. The third is the low carbon and clean performance. As we know, in China, we are constructing the zero carbon park and the zero carbon factory. The core path for the construction of the zero carbon parks and the zero carbon factories is the self-consumption of the green energy. That means we consume the photovoltaic power or the wind power in the park or in the factory locally. So most parks still rely on the fossil fuel energy for power supply to make it difficult to achieve the true zero carbon. GE's smart microgrid precisely solve this problem through what we call the South Grid Load Storage integrated practical configurations, the four-path configurations. So with all technical solutions based on the actual implementation experience of JA's own zero carbon factories and cooperative parks. The fourth one is the economy. At present, the smart microgrid application, as our experience, generally face some problems, high construction cost, but low operating benefits. Most projects only achieve the energy supply, but cannot recover the cost through market-oriented operation. JA's smart microgrid solves this pain point through resource aggregation and market-oriented participation, achieved both goals of energy supply and economic benefits. Also helps enterprise to reduce their power cost through precise load scheduling and energy management. At the same time, J's smart microgrid as an independent aggregation node through the EMS system or developed the EMS system. It integrated the adjustable loads in the grid, such as the park air conditioner and the factory backup equipment, and also to integrate the distributed energy resources for the photovoltaic wind power and energy storage system to form a schedulable, flexible resource package. We can use it to participate in the local power market transactions. So we also participate in the demand response and the virtual power plant operation to increase the operation benefit. So from these 4 aspects, the advanced smart microgrid can support the grid and energy system more safe, more reliable, and more clean and more economic. Okay, thanks.
Thank you, Yankun. Okay, so what we see from this round is that the innovation is not only happening in just one part of the system, but it's also happening across products, across system design, digital platforms, and also the real-world applications. So now I want to close our round. A big thanks to all of our panelists for such thoughtful and forward-looking insights. Today's discussion has shown very clear that the future of the solar and storage will not be defined by only one single market, one single model, or one single environment. It will be shaped by how well we can adopt solutions to very different scenarios, from deserts to cities, from remote communities to high digitalized energy systems. And as these applications continue to expand, success will depend on not only the technology performance, but also on integration, resilience, and the ability to respond to real-world needs. Thank you again to all our distinguished guests, and thanks to everyone in the audience for staying with us. And now back to you, Xiangling.